So hello everyone, this is lecture 30 for the classical physics. In the last lecture we were discussing about the canonical transformation equations, in which we convert one form of generalized coordinate to the another form. Okay, and we use these generating functions. Means if this is your function in this form, small q and capital Q, then you can find small p and capital P. They will be dependent and they are the independent coordinates. Then that's how you can find the new Hamiltonian. That is from here. That is, this is your new Hamiltonian K. It will be h plus delta f by delta t, where this f is generating function. So that's how you can convert them. So I already explained you everything here. Now we will see this application of these things. Means the questions. So what kind of question can be asked in the exam from this part? Okay. So let's see. Find the transformation corresponding to generating function f1 small q capital Q. If h is q square plus p square is Hamiltonian of the system, then find the Hamiltonian in the new coordinate system which contains q and momentum p. Means the new coordinate q and momentum p. So we need to find the new Hamiltonian. So generating function is given and old Hamiltonian is given. So we need to find new Hamiltonian. So we'll use this formula k equal to h plus del f by del t. Now h is given q square plus p square. So h plus, and this is not a function of time, so del f by del t will be 0. So k equal to q square plus p square. But see, these coordinates are old generalized coordinate. We need to find new coordinates, capital Q and capital P. Only then we can say that this is your new Hamiltonian. So let's find how you can find. So this is f1 because it includes small q and capital Q. So from here you need to remember this table. So it is small q and capital Q, so you will call it f1. So from here you can find p, small p and capital P. So that will be small p equal to del f1 del q. That will give you capital Q. Now capital Q equal to p, and capital P from there will be minus del f1 divided by del q. Means this is a differentiation. It will give you minus q. So you have q equal to minus p and capital Q equal to p. Now you have this Hamiltonian q square plus p square, and k was also came out to be equal to q square plus p square. Now you need to substitute in place of q in terms of capital Q and in terms of p in terms of capital P. So it is h plus del f by del t. This is 0 and this h is q square plus p square. Now what is q? Q from here is p minus p. So it will be p square. And what is small p? That is equal to q. It will be q square. So this will be your new Hamiltonian in terms of capital P and capital Q. Let's see one more question. If q equal to minus p and p small p equal to capital Q are transformation equations. So if transformation equations are given, then find f1 type generating function. So we need to find the generating function. So how can you do this? So let's see. If this is f1, then you know these equations, small p and capital P. So let's write these equations. Then let's see what we will get. So q equal to minus p and small p equal to q. This was your question. We need to find f1. So small p will be del f1 divided by del q. That will give you q. How? I wrote it from here. Small p equal to q is given. So this should be equal to this. And second equation is capital P equal to minus del f1 divided by del q. So this should be equal to p is equal to minus q. That should be equal to this. Now you have this equation and this equation. So we can solve this by using the integration. Del f1 equal to q del q. Now integrating this will give us q here and some constant that will be function of capital Q. Why it is function of capital Q? Because when you differentiate this, then it will give you del f1 here, and with respect to q it will give you this q del q, and what will be here? It is function of capital Q. So when you differentiate with respect to small q, that will give you 0 here. So that's why the constant should be function of capital Q, so that you will get 0 here when you differentiate, and you can get this equation again. Okay, so that's why we have written this constant as function of capital Q. Now you have f1. Now try to solve this equation. Del f1 equal to minus q del q. So it will be again del f1 equal to q del q. So from here you will get this constant. It is function of small q now, because to get this equation, if you differentiate it with respect to capital Q, this you will get this equation again. Now see, this f1 is this and f1 is also this. So they should be equal. So if you equate them, then this is the same thing. So this should be 0 only, then they can be equal. So what is your function? Now you can find generating function, nothing but q small q. So this will be your generating function. So that's how you can find your generating function. If this kind of question is given, means in the question, if equation of motions or the transformation equations are given, if transformation equations are given, then you can find generating function very easily using the same method we discussed here. Let's see one more question. A mechanical system is described by the Hamiltonian H QP equal to P square by 2m plus half m omega square Q square. So Hamiltonian is given. As a result of the canonical transformation generated by this means generating function is also given minus capital Q by Q. Now the Hamiltonian in the new coordinates Q and momentum P becomes. So we need to find the new Hamiltonian. So it's the same this question. Means F is given, Hamiltonian is given, and we need to find Q and P. So we'll use the same thing as we did here. So now see, this generating function is in terms of small q and capital Q. So which generating function it is? It is F1. So we'll use these equations, small p and capital P. So you need to remember that table. Now see how you can solve this. So first we know how to find the new Hamiltonian, that is by this relation k equal to h plus del f by delta t. So h is given already, this one, and so it will be h plus del f by del t, and f is not a function of time because it is minus q by q. So this will be 0, so k should be equal to h. Now h is p square by 2m plus half m omega square q square. This is given in the question. Now this is in terms of small p and small q. So to write the new Hamiltonian, we need to replace them with the capital P and capital Q. So how can we find that relation? We find that relation from here using this. Small p will be this and capital P will be this. So after solving this, you will get a relation between Q and P. So that's how you can substitute. So from here you will find small p is equal to capital Q by Q square. You will find the differentiation, and then you will find capital P will be minus del f1 by del q using that equations. So you will get 1 upon q. Now see capital P equal to 1 upon q. So you will substitute here in place of p 1 upon q. You will get in place of 1 upon q you will substitute 1 upon p. So that will give you 1 upon q square will give you p square. So this can be written in this form. Now small p is equal to capital Q p square, and small q is equal to 1 upon p. So you will substitute in place of p and q. You will get this is your new Hamiltonian. So these are very basic things. So you can use a simple equations and you can solve these questions. So there was one more question. In that Hamiltonian was given, and you need to find a new Hamiltonian again using this generating function. So I have not given you the complete question because this was a basic thing asked in the question. So I'm just saving some time. So Hamiltonian is given, we will solve this question just like we did here. So Hamiltonian is given, we need to find new Hamiltonian in terms of capital Q, capital P and T, and generating function is given in terms of small q and capital Q. So it is again F1. So you will use the same equations you used here, small p and for the capital P, and we will solve this, and new Hamiltonian will be k equal to h plus old plus del f1 divided by del t. So it is not a function of time, so this will again give you 0 and it will equal to h. So k will be this Hamiltonian. Now you need to replace small p and capital Q, small q. So you will use the equations and find the relation. So p will be this and capital P will be this. Now from here you can find the relation between q and p. So from here q will be equal to this. Now in place of this you will substitute this value. So you will get p in terms of its capital terms and you will substitute it here and you will get your new Hamiltonian. So small p will be this and k is equal to, after substituting values you will get k equal to omega capital P. So that will be your answer. Now see in this question, if it was given that capital Q at time equal to 0 is equal to 0, then you need to find a relation between q and t. Means you have to find the function of q in terms of t, and there was some graph was given in the question. So you need to choose that which graph is correct. So only when you have the function between q and t, then you can find that what kind of graph you will get. So let's see, to find the graph between q and t, what you need q dot, that is dq by dt. So for that you need to find the q dot. So capital Q dot how you can find? So you know the equations of Hamiltonian. So for q dot it will be del k by del p. So this is the same equations we used in the Hamiltonian, where it was small q dot, it was equal to del h by del p. This is the same in the bus. It is in the, now here in the new coordinate or the new generalized coordinates. Okay, so q dot equal to del k by del p. It will give you omega from here. Now from here you know that this is dq by dt, so it will be dq equal to omega dt. From here you will get q omega t plus c. Now this condition is given, initial condition, at t equal to 0 this q will be 0, so c will be 0, so q equal to omega t, this will be your relation. Now if you plot this, you will get this kind of curve. Q and t will be a straight line. So this kind of question can be asked in the paper, means you need to plot this. So that's how you can plot. Now there was this another question in which this relation transformation equations was given. Capital Q equal to under root q square plus p square, and generic function was given, that was 1 upon 2 q square plus p square tan inverse q by p plus half qp. And what we need to find here, find capital P in terms of q and p, and find f in terms of q and q. So this was the question. So see, first we can find this f, because in here we have p, small p, and small q, and we need to find in terms of small q and capital Q. So we need to remove only this small p, so we can remove it from here. So from here you can find this relation, this will be equal to q square equal to q square plus p square. So p square will be q square minus q square. So you can substitute in place of p square, that is q square minus q square. So this will be your relation. Now substituting here, you will get your f in terms of small q and capital Q. So this will be your answer. Now in options it was given in sign inverse, so you must know how to transform according to the options. So you know how to convert this. This is p upon b, so you need to find the hypotenuse, that will be square of this and this, adding you will get hypotenuse, then it will be q upon, that will be capital Q. So in sign inverse you can write this sin inverse q upon q, this one. So that's how you can get this your f in terms of small q and capital Q. Now see, you need to find this p in terms of q and p. So how you can find? See, this generating function is given in terms of small q and p. So what equations we will use in q and p? Small q and small p. But see, you can't write your generating function in terms of order, only on the order variables or only in the new variables. So this must be changed. So you find it this generating function in terms of small q and capital Q. So this was this. Now this is in terms of small q and capital Q. So you will use, this is your f1. So you know what equations we will use, that is for the f1 from there. So from there, capital P will be equal to minus del f by del q. Now you know what is your f. F is equal to this. So you need to differentiate it with respect to q, capital Q. So partial differentiation. So you will use product rule here and simple rule here, chain rule here. So let's find the derivative. So that will give you minus q sin inverse q by q minus q square by 2 1 upon under root 1 minus q square by q square multiply minus q by q square minus q into 2q 2 multiply 2 under root q square minus q square. So I just used the simple differentiation. You know how to find this, and I dictated you every term here so that you can get it correct. Okay. Now when we solve this, this will be minus q sin inverse q by q. This will be minus, and minus will give you plus here, and here you will get minus term. So they both will be same and they will cancel out each other. So you will get your capital P equal to minus q sin inverse q by q. So now you need to find this P in terms of small q and small p, but you have here this capital Q. So you need to remove this capital Q in terms of small p. So you know this relation, we already find it this. Is q square is equal to p square plus q square. So you will substitute in place of q under root p square plus q square. So this will be your answer, means for the p in terms of small q and small p. Let's see one more question. So transformation equations were given, capital Q equal to q square and capital P equal to p upon 2q. So these transformation equations are given, and you need to find the your generating function. So see, when you see, I have seen in the options. So in options the function was given in small q and capital P. So from there, after seeing them, you know how to which function you need to find. Okay. So if it is given in terms of small q and capital P, all the options, then which one you will use? Small q and capital P. So you will use f2, means you need to find this f2. So you will use these two equations, and then for this equation you will get del f equal to p del q. From here del f2 equal to q capital Q del p, and then you will use that equation, you will solve, and you will get your f2, just like we did here in this question. You will get the same. So let's see one more question. So in this question again, Well, here in this question, your generating function was given f equal to q square p, and you need to convert or the transform your old coordinates to the new coordinate system, and you need to find a new Hamiltonian. Okay, so function is given and you need to convert them, and old Hamiltonian is given p square by 2 alpha q square plus beta by 4 q4. So this was your question, means find the new Hamiltonian. So let's see the solution. New Hamiltonian will be h plus del f by del t. So this is your f. So h is this, so we'll write h as it is here, and it is not a function of time, so we will get 0 here in place of del f by del t. Now see, we know this relation from here, means after seeing this generating function, it is a function of q and capital P. So which equations we will use? So from small q and capital P, we use these equations. Small p and capital Q will be these. Okay, so let's see. So small p will be del f by del q, and we know what is f. F is this, so it will give you 2 qp, and from here capital Q will be del f by del p, it will give you q square only. Now from here small q equal to under root q, and from here this p square will be 4q, means this p square will give you 4 q square p square, and from here q square equal to capital Q, so you will get p square equal to 4 capital Q p square. Now you have small p and small q, so you can substitute them here and you will get your new Hamiltonian. So it's just a simple thing. You must know how to solve these questions. So you know small p, you know small q, substitute here, you will get your new Hamiltonian. So this will be your new Hamiltonian. Now if they ask you to write the new equations of motion, then you know how to write the equation of motion for the Hamiltonian. Capital Q dot will be del k by del p. So you remember them from Q dot equal to del h by del p, and for p dot there was del h by del q. So in place of new coordinate we have new Hamiltonian, that is k. So in place of h we will write k, in place of small q we will write q, capital Q, and here there will be capital P. So you can solve this using this new Hamiltonian. So these are the same things. Now let's see one more question. So we need to find a new Hamiltonian, and this old Hamiltonian is given, and generating function is given, capital PQ minus half p square t. So it is given in terms of small q and capital P. So you know which equation should be used here, and h is given, so k will be h plus del f by del t, and it is function of time. So what you will get here, you will get minus 2p will give you minus p here. So well, we need to find a partial derivative here. So del f by del t will give you, this will be 0, and here you will get minus p square by 2 only, because this will be 1. So you will get here minus p square by 2, because this is h plus del f by delta t. So this is your new Hamiltonian. Now you need to remove these small q and small p. So you will use again the same equations. When you use that equations for the f2 function, from there you will get small p equal to capital P and capital Q equal to q minus capital Pt. Now from here you can find small q, that is equal to capital Q plus Pt, and you have small p. You will substitute here simply these things, this one and this one. You will get your new Hamiltonian in terms of capital Q and capital P. So this will be your new Hamiltonian. So that's how you can solve. So I'm giving you to solve these questions because you must know how to solve. Otherwise I can give you definitely the solutions. So let's see one more question. So this is a quite good question. So transformation equations are given. Capital Q is given log 1 plus under root q cos p, and capital P equal to 2 1 plus under root q cos p under root q sin p. And we need to prove that generating function for this is f3 is equal to minus exponential capital Q minus 1 square tan small p. So we need to prove this, that for these transformation equations generating function is this. So see, if you need, this is your generating function, that which equation should be used. So it is in terms of small p and capital Q. So from there you can see you will use these two equations for the f3, both should be negative. So you will use these equations to find del f. You will use the same method as we discussed, del f equal to q del p and del f equal to p del q. You will find f from both these equations and you will compare, then you can find your f. So Let's see how can we find. Let me find one for you, then you can find the second one. So let's solve this equation. From here we can see that log this is equal to this. So this must be equal to exponential q. From here we'll find the value of small q in terms of p, so that we can just integrate this in terms of dp. That's why we are finding the value of q from here. Now it will be under root q cos p exponential q minus 1. So from here this cos p will go into the denominator, so q will be square of this and cos square p. Now see f from here will be q dp del p and minus q del p. So minus q will be this and del p. So this will be sec square p here, and sec square p integration will give you 10p. So and some constant in terms of capital Q, definitely. Now you have this f3 and this is some constant. Now see, you will try this second equation, p del q. Now you need to find the value of p, so that you can solve this in terms of q. So how you can do that? You will try to solve this equation. How? You will substitute in place of q this one. In place of small q, you will write this term here in place of small q, and you will get your equation in terms of small p. Then you can simply integrate p del q. So then you will again get some function that will be in this form only, means again you will get this thing and fq or fp. So this is same in both the functions, so this must be 0 in both the equations. So your generating function will be this minus exponential q minus 1 square 10p. So that was the question, means we need to prove the same thing. Okay, so that's how you can solve this. So it's a good question, you should try. So let's see one more question. H of a system is this. H is given p square by 2 plus q square by 2. We need to find the new Hamiltonian by considering the canonical transformation. So old h is given, you need to find the new h. So it will be k equal to h plus del f by del t. So you must try this question. This is a very good question. So I will give you a solution in the next lecture. For here, you know this generating function f equal to 0 to q under root p minus alpha square d alpha minus pt. And these were the four options were given. Capital P q minus capital P by 2 minus capital P q by 2. So the C option was correct. You must try this question. And one more question you should try. Consider a system with 1 degree of freedom and canonical coordinates small q and small p. If the Hamiltonian of the system is given h equal to 1 by 2 p square, and canonically transformation equations are given by capital Q equal to log sine hq divided by p. So this is hyperbolic q, and capital P is given small p cos hyperbolic q divided by sine hyperbolic q. Then find the new Hamiltonian in the new coordinates. So these were the four options given, and the C option is correct. So try to solve this question. In the next lecture I will give you the solution. So that's it. Thank you everyone.